Hey, what's up everyone? So today we are going to solve this course schedule problem from leetcode. So let's begin. So what this problem is telling that there are total of num courses. Okay, you have to take labeled from 0 to num courses minus 1. Okay, fine. So suppose if we have num courses from uh, if we have 5 num courses, then we can take from 0 to 4, right? So this is the first thing. Okay, so you are given an array prerequisites where prerequisites I equal to ai comma bi indicates that you must take course bi first if you want to take course ai, right? So I'll explain you. For example, if we have ai and bi, right? If we have these two things, so for example, ai is 2 and bi is 3, so we need to take course 3 before we have to take course 2, right? So course 2 is dependent on course 3, means course 3 should be completed first before taking course 2, right? So this is what it's saying. Fine. Now what? For example, the pair 0 1 indicates that take course 0, you have to first take course 1, right? Yeah, for example, that return true if you can finish all courses, otherwise return false. So this is a classic cycle problem of of graph cycle detection problem. So how I'll explain you with example. So suppose we have suppose we have 6 element, right? 6 num courses, and we have elements from okay, I will make a diagram here. Fine, let me clear it. So suppose that I have 1, I have then 2, then 3, then 4, then 5. So our num courses is 6, right? 6 is our num courses, so I can take elements from 1 to 5, right? So 1 2 3 4 5, and let's make some edges. So 1 is directed to 2, means 2 course 2 should be finished before we have to finish course 1, right? So for finishing course 2, we should finish course 3, and suppose that 3 is directed to 5, and 4 is directed to 5, and suppose 1 is directed to 5, right? So yeah, so you can see that there is no cycle here. 1 2 3 5 and 1 to 5 and 4 to 5. So you can see, so this will give us 2, and if we have suppose we have 5 to 1, right? So what is happening here? So before finishing course 1, we have to finish first course 2, and for finishing course 2 we need to finish course 3, and for finishing course 3 we need to finish course 5, and for finishing course 5 we need to first course 1, right? So this is a cycle dependency which should not be exist there, right? So how we can solve this problem? We just need to determine that if there is cycle dependency, right? If there is cycle dependency, then we need to return false, otherwise we will return true, right? So let's begin our solution. So how we will determine the cycle dependency? So so for example, we have 1 and then 2, then 3. Okay, so this is 3, and 3 is making cycle with 1, right? So 1 2 3 and 3, then again 1. So what we generally do in DFS is, you may be thinking, right, if we will keep marking visited, and if we will visit that again, then our cycle is formed. For example, we start traversing from 1, right? We start traversing from 1, then what will happen? This is suppose this is our visited array. So this is 1 2 and 3, right? So initially they are 0, right? So if we start our DFS traversal from here, DFS traversal from 1, then what will happen? After traversing it, we will keep it 1, then after going to 2 we'll mark visited as 2, and in visited of 2 we will mark 1, and after going to 3 we will mark visited as 1, right? Then 3 is pointing to again 1, right? Then if we found that again we have 1, then yeah, we can say that this is cycle. This graph contains cycle, right? But let me take you another example. Fine. So for example, suppose we have 1 and then 2, then 3, then this is directed graph, and we have also one edge to direct 3, right? So for example, this is our visited array, right? So this is 1, this is 2, this is 3. Fine. So we will traverse, we start our traversal from here. We will mark it as 1 after visiting it, and after that we will go to 2 and we will mark it 1. Then after going to 3, right, we will mark it 1. After going to 3 there is no more edges, and then we will return to 2 and we will say there is no more edges. Then after returning to 1 we will see that there is an edge between 1 to 3, but 3 is already marked as visited, right? So many people do this mistake, like if already visited, then they will tell that there is cycle, right? But you can clearly see that there is no cycle. 1 is going to 2, 2 is going to 3, and 1 is going to 3, and there is no any cycle, right? So this doesn't contain cycle. So what is our solution, like how we will approach this problem? So for solving this problem, we will make two visited array. One will be a temporary visited array. Fine, let me clear you how we will made it. So as soon as like this is our temporary visited array, this also contain 1, 2 and 3. So we will start our traversal from 1. So we will mark it as 1 after going to 1, right? Then we will go to 2, then we will mark it 1, then we will go to 3, then we will mark to 1. Then see, there is no more any edges, right? So we will backtrack from here. So while backtracking, right, we will mark again as it is 0, and when we will reach to 2, then we will see that there is no more edges, right? So we will backtrack to 1 and we will mark it as 0, right? Okay, I will mark it clearly 0 and then again 0. Then from here we will see that we can see that there is edge between 1 to 3. So we will visit 3 edge, right? So we'll mark it as 1. So in this way we will detect a cycle, right? So we can clearly see that this edge is this graph is not forming any cycle, right? So yeah, this doesn't contain any cycle, so we'll return true here. So let's solve our problem. So the basic idea is, if we found a cycle, then we will return false, otherwise we will return true, right? Okay, so let's begin our solution. So first I will make a DFS. Let's write our DFS function. So I will make it return type. Okay, I will see later. So DFS, our standard template of DSS will be our current our current value plus our visited array and our graph. So we will make it a vector of list, right? So first of all, what we do is we'll mark visited of current equal to 1. Then after that we'll traverse through each edges. So for auto x graph of current, we will traverse through each edge of that current node, and if we found not visited of x, like if this is not visited, then we'll simply traverse our DFS, right? X and visited, and graph. And this is a standard template of DFS. So we have to make some changes. For cycle detection, we are passing again temporary visited array, right? So in temp visited, right? So we will, as soon as we visit an edge, a node, we will mark the temporary visited and visited as one, right? So temporary visited of current equal to 1, and the end, what I will do is I will mark temporary visited of this node equal to 0. So I will keep marking it. After visiting, I will mark 1, and after going from this, I will backtracking, I will mark it as 0, right? So what will happen is if my temporary visited, if I found like temporary visited of x equal to no, I will not write it here. If temporary visited of x equal to 1, right? If it is already visited, right? If my x is already visited, then what I will do is I'll just simply return false from here. So for that, I'm making a temporary variable. So that will be so let's suppose that flag equal to 1, and I will return from here, and I will declare my flag globally from here, and flag equal to 0, and I will return from here, right? So I will make it void return type, and this is our DFS function. And I have to make a build my graph. So let's build my graph. So first of all, what I will do is I will create a list vector and graph, and its size will be num courses. So we are taking from 0 to num courses minus 1, right? So num courses, fine, and num courses, and I have to make a visit array, and its size will be also num courses, right? And I will initialize it with 0, visited 0 and num courses. Okay, sorry, size of visited, fine. And there is also my temporary visited array, so I will declare it temporary visited, and size will be num courses, and I will initialize also it with 0. So temp visited 0 and size of temp visited, right? So after that, what I will do is I will iterate I will iterate from this prerequisites, and I will make my graph. So this will be for auto suppose we are taking vex and prerequisites. I think spelling is correct, prerequisites. LeetCode doesn't give my spelling suggestion, which other code editor like VS Code or Sublime gives, right? And Gigs for Gigs, I think also gives vex prerequisites, and then for x, I will iterate through each vector inside my prerequisite. So vex and the first and second element, right? I will take. So now, or else I can do it as int a equal to vex of 0, because we have only two elements, right? For example, you can say this is 1 0, so this is 1 is vex of 0 and 0 is vex of 1. For example, here you can see this is vex and this is also vex, so I'm taking it and b equal to vex of 1, right? Then I will build my graph of A dot pushback B. So this is my directed graph actually, so that's why I'm doing only this, right? Fine, great. Now I will iterate through each num courses. I think, yeah, I'll iterate through each num courses, and I equal to 0, I less than num courses, and I plus plus, and if after I will iterate to each my graph, right? So for auto x and graph of I, all right. So if my node is not visited, right? If my node is not visited, then I will call my DFS function from here. So x and visited and temporary visited. Okay, this is my graph and this is my temporary visited. I will also call my temporary visited from here. Temporary visited. Fine. Okay, so and after calling this DFS function, I'll keep checking my flag. If my flag will be 1, then I will return false from here, right? And if I didn't find any cycle, right, then I will return true at last. Fine. So I think our solution is pretty much correct, right? If not visited, for right. So let's run our code. I think this gives me right answer. Let's submit it. Oh, great, our solution is correct. So thank you so much, guys. Suggest me some more question, comment down, and like if you like this video, and dislike if you do not like this video. And thank you so much.